It's 1:30, so let's go ahead and get started. I want to take this opportunity to come up here, represent the code team to actually welcome Jonah here. So Jonah is an SRE at Stripe, and having him come here really solidifies a lot of the messages that we're really trying to talk about when it comes to containers and how Jonah and his team are actually doing a lot of this stuff in production. So it's a good way for not only us to just sit here and try to educate you all about containers, but to see that there really are companies that are doing this, maybe not in a lot of large enterprises, but there are a lot of companies that are living on the bleeding edge of trying to make sure that they're pushing the organization, pushing the technology to the next level. So with that, I want to go ahead and say, first, thank you, Jonah, for actually coming here today and presenting on behalf of the code team, and one less session that I have to deliver this week, so that's a positive. But with that, go ahead and take it away.
Thanks, Kenny. Thanks for that introduction. Good afternoon, everyone. When I got my very first tech job, I was still in high school, and I got an internship with Sun Microsystems. I remember on my very first day, I sat down with the engineer who was mentoring me, and he manually created my home directory. He manually edited Etsy password and group files and copied them across the systems that I would be working on. See, it was 1994, of course, and it was the beginning of the use of the World Wide Web. That was what our team was working on. We hadn't even finalized HTML 2.0 yet. We did all of our development on local workstations, and when we were ready to release code, we just FTP it up to the web server. We had no source or revision control. I worked at several tech companies since then, and the process for managing servers has obviously gotten better over time. My name is Jonah Horowitz, as you know. Right now I'm a site reliability engineer at Stripe. I'm on the resiliency team. Our job is to look out for the risks that exist across the production infrastructure and try to mitigate them. We work directly with the software engineering teams to find and resolve issues before they create downtime. We also take the things we learn from incidents and make sure that the issues that cause those incidents are mitigated across the entire Stripe infrastructure. Before coming to Stripe a few months ago, I worked at Netflix. I was with the Netflix core SRE team. We're the team that responds to all customer-facing production issues at Netflix. I've also, pretty recently, I worked at an ad tech company called Quantcast, and just so you know that I've done bare metal infrastructure relatively recently. And we rolled out, we had thousands of clusters running multi-petabyte sorts on big data, on analytics data that we were collecting to do ad targeting. Just as a housekeeping note, my Twitter handle is @JonahHorowitz, and my speaker deck is already up on speakerdeck.com/JonahHorowitz if you want to take a look at that. You have to take pictures of the slides. So, just let me give you a little bit about Stripe. Stripe is a software platform for starting and running an internet business. It's what hundreds of thousands of companies, from small YC-funded startups to Fortune 100 companies, use to sell to customers everywhere in the world. Our goal is to increase the GDP of the internet. So this means making it easier for more offline businesses to move online and also get more new companies around the world started. We're known for having a really great API that allows developers and their companies to get up and running really quickly, taking payments with just a few lines of code. More recently, we've been helping entrepreneurs all over the world launch internet businesses with Atlas, which is a toolkit that helps a company get their incorporation papers done and all their bank accounts opened in the United States so that they can start taking payments. If you want to know more about Stripe, come and talk to me after the slide. So, at Stripe, and now I think at most companies, we've gotten used to the idea that we have to manage our infrastructure with code. It's impossible to scale, hand logging into systems or even just writing shell scripts. Imagine if we still had to do what that Sun engineer did when I started back then. And the first step for many companies when they start moving away from shell scripts is to use one of these tools, right? Ansible, Puppet, Chef, SaltStack. Really robust tools, large user communities, lots of existing code to reuse and copy. My first experience with these tools was in 2007. I joined a tech startup, and there was my manager there had already really got excited about CF Engine, which 2007 was pretty cutting edge. We implemented it with passion. We had every server in our entire production infrastructure such that we could shoot it in the head and reboot it and rebuild it within an hour. Everything except for the database servers, and I will come back to that point in a minute. We had everything automated. Our release engineering process was still pretty painful. We hand-edited configuration files and then pushed those to the production environment for every step of the release process. I had sort of thought maybe I should write scripts that generate those configuration files, and then maybe I should have a configuration management tool generate those scripts. These jokes aren't going to get me fun. Once you start managing your infrastructure as code, your systems engineering team starts ending up to look like a lot like your software engineering team. You know, they're focused on a different level of the stack, but they spend most of their time writing and deploying code, not logging into individual servers. And then, once you start doing that, your network engineering team gets jealous, and they want to do the same thing, so they start using software-defined networking to automatically provision network switches and other networking gear. But there's a flip side to this. There's a downside to configuration management. From what I've seen in production, there's basically two ways of running configuration management. In the first mode, you've got an operations team that bottlenecks all of your code releases to production. They're the only ones with commit access to your production repository, and they have to make all changes. This is essentially the antithesis of DevOps, right? The other option is that you expect developers to learn your configuration management tools. It's not that they're not capable people, but it's just not within the realm of things they normally work on. And when they do have to touch it, it's something they're not used to. You give every engineer access to your configuration management software, and now every developer now has the power to take down your whole system with a poorly written configuration change. I once had a developer a few years ago release a piece of code to production, and he had put a line in there that he thought would be innocuous, but it killed everything owned by root on every system, except for init. So the systems were still running. They just didn't have syslog, and they didn't have cron, and they didn't have sshd, and they didn't have rsyslogd. So we had to fix them by logging into them using the serial console ports on every server. One at a time, 4,000 nodes, 7 word diceware passwords. You can imagine what a ridiculous pain that was. So you can fix that problem, right? You can at least have separate configuration repositories for each one of your production environments. So at least your developers can only shoot their own team in the foot, and they can't kill off a whole bunch of people's work. But then you have to manage the common infrastructure code, right? How do you manage the monitoring packages that you put on every server? Do you fork everything? Do you have a Git submodule? I mean, everything that you can use to solve that problem ends up being kind of messy. And then anyone who's run configuration management at scale has run into this problem, which is that your fleet is never exactly up to date, right? There's some percentage of your fleet that's a little behind. And this is for many reasons. Either the servers that run the configuration management tool are not available, or maybe your servers don't run configuration management all at the exact same time. They're staggered by a few minutes. You've got broken networks, buggy code, bad configuration management pushes, whatever you can, you name it. Something's always out of sync. So you can write a bunch of code to handle that problem. I remember having systems where I had Nagios checks that would fire if one of my servers hadn't run its configuration management software in the last hour. I even had scripts that would autocorrect for that. They would retry. But no matter what you do, you're always going to have some unpredictable part of your infrastructure. Hey, look at that. And then, this isn't unique to configuration management environments, but it's certainly enabled by it. There's that one server, that one snowflake that nobody has gotten around to automating yet. That one server that's a single point of failure. That one server that nobody has gotten around to backing up yet. That one server that Bob, who left to go work at Huli, built. And no one knows how to rebuild. Yeah, that one server. And sadly, that frequently is the configuration management server. Anyone seen that pattern? So obviously, configuration management has its challenges. What are the alternatives? So before I go into alternatives, I want to talk a little bit about Netflix, because If you're not familiar with Netflix's environment, it's got pretty insane scale, right? It's got 100,000 instances running across 3 AWS regions, and by 100,000 I mean that's the average number of instances. It scales up and down by 20% every day, which means it's killing and rebuilding 40,000 production servers every single day. There's a great talk on this that one of my coworkers at Netflix gave. The link's in the slide. The slides are on the internet, so you don't have to try typing that. But Netflix. Another thing about Netflix's scale that's super important to understand is that they're doing 4,000 production releases a week of software. So they need a way to roll out production changes without using configuration management, because configuration management was slowing them down. And they moved to immutable infrastructure. If you're scaling up and down every few minutes, you can't wait for your configuration management software to kick in and configure your servers. How many people here have heard of the term immutable infrastructure? Anyone? Okay, so like 10 of you. So for the rest of you, here's how it works. The idea is you don't run configuration management in production at all. You build and configure your servers when new software releases are put out, and then it's never touched. Once you are ready to deploy the next version of your software, you actually deploy a full stack from the operating system all the way up. And at Google, they even cryptographically sign every release so that they know that the servers that are running in production are the ones that they expect to be running in production. And they can always test to see if that server is the one I think it is. So, you start with a base image. This is a lightly optimized, take Ubuntu or whatever your operating system of choice is. Make some configuration changes on it to match your infrastructure. At Netflix, this was done by the performance engineering team. Make sure the security updates are on it, so work a little bit with your security engineering team. Get your base infrastructure packages, things like monitoring and service discovery packages would be installed. Then you need a release process, so we used a canary that would go out to some of the less critical teams about once a week. And then once that canary was validated by less critical pieces of the infrastructure, it would roll out to the production infrastructure. Obviously, you need a faster release process for this if you're going to have some critical security update, and we could roll that out pretty quickly. So once we have that base image that's used for all of our production servers, we install the application package and its dependencies using your standard package manager. So this is apt-get or yum. We compile that, base image plus application package is compiled into a new machine image and released to production. Ship that to all of your Amazon regions, ship that to all your data centers, spin up as many servers as you need. So, of course, so far I've been talking a lot about how Netflix did this. We're at the Dell conference. I assume a lot of you still have production hardware. You can do this similar thing using Docker. So you're running something like Kubernetes. You've got that deployed across all of your bare metal infrastructure, and then you release Docker Docker machines on top of that. Docker itself is already essentially immutable. And it can be built using the same operating system package deployment tools. In fact, if you're using configuration management to manage the insides of your Docker images, you're doing it wrong. Don't just take my word for it. I have friends at Docker, I have friends at Puppet, I have friends at Chef, and they all agree with me. You should not be running configuration management inside your Docker images. So that handles how we manage the application, but how do you manage the base OS and the operating system, right? It's possible that you still need some amount of configuration management to run that, but instead of every application developer and every team needing to have access to your configuration management repository, you're talking about just your data center team or whoever manages your operating system on your servers. You can get that down to maybe, I don't know how big you guys are, but 10 or 20 people is the most I've ever seen that needed access to that sort of tooling. It's also possible to push this further. I've seen companies actually boot all their machines off of a built-in image and then run Docker on top of that. It's a little more complicated. You need to be a little more flexible, but it's totally possible. So let me talk about some tools that you need to make this work. You're going to need some sort of package builder, right? You take your application packages and you need to compile them into a usable form. So for this, Netflix uses Gradle. You could also use a tool that comes with your operating system, RPM build, or build deb on Ubuntu. Next, you need a system to build your images. Netflix uses Aminator, but if you're familiar with Packer from HashiCorp, it's an amazing tool. It works with Amazon, Google Compute Engine, Microsoft Azure, Docker, and a whole bunch of other ones. So, huge fan of Packer if you have a chance. And then, if you're using Docker, you can just use Docker build dash IT to run it. For managing your deployments, you need a deployment tool. Netflix uses Spinnaker. It's open source. It is my favorite Netflix open source tool. Every time I get in front of a group of people, I talk about it. It's how they run all of their release pipelines, from the point of check-in through managing the servers in production and even switching to new builds of the production environment. It's open source. It runs, again, like Packer does. It runs in Azure. It runs in Amazon. It runs in Kubernetes environments. So no matter what kind of site you're deployed on, you can probably make Spinnaker work. And then if you're running the same images in test and prod, and your development environments, maybe some of your staging environments, you're going to need some discovery tools. So Netflix uses Eureka, but Zookeeper, Consul, Kubernetes, Docker all have tools for doing this sort of thing. So why would you want to do this? First, it totally simplifies your operations. You no longer have to know the state of your currently running servers to release a new version of your software. You no longer have to think of how to get from point A to point B. You don't have to log, if your servers are broken, you no longer have to log into them one at a time to fix them. You just simply blow them all away and launch new ones. And I'm going to say that all again because I think it's super important. You don't have to get from configuration A to configuration B. You don't have to worry about, hey, if I write this script that's going to update this configuration file, is it going to double that line in the configuration file and break my configuration on all of my servers? You don't have to worry about it. You just ship the new configuration and you destroy the old one, and you never have to worry about it. This enables continuous deployments because new code just goes through your pipeline and releases to your staging environments, to your QA environments, and then your production environments. And you don't have to worry about old versions of software, old configurations, or old binaries that are left around on the system. You can quickly start up new instances of your software when you need to scale. I've seen configuration managed environments that take 4 hours to get a system fully up and running before it's ready to take traffic. That's probably a pathological case, but even in a normal environment, it's pretty standard for it to be an hour before a system that's been launched is able to take traffic. It's hard to reactively auto-scale to incoming demand if you have to wait an hour for every system to come up. And it's also hard to recover from failure, right? If Chaos Monkey kills one of your instances, if one of the machines in your cluster dies, if data center tech unplugs one of your machines, you need to be able to get that instance up quickly. Well, if you have immutable infrastructure, you're literally just saying, hey, launch another one of XYZ instance, and you're back up and running. Think about it, it's a lot like when we were in CS1, or if you have a software engineering background, where you spend a lot of time optimizing stuff at compile time, so your image build process is a little bit longer, but your runtime is significantly faster. In addition, right, your configuration is in sync across all your nodes because you have no changes in state in your running system, so you just launch them all, and if you add 5 more of them, they're going to have that same state. You don't have to worry about a few of your machines being out of sync with your other machines. They're all running the same. And you don't have any cruft building up in parts of your systems. If one of your nodes is like acting weird and you're not sure why, you can just kill that node and replace it with a new instance. When you deploy the same image to dev, test, and prod, you can trust the systems to behave the same in each environment. And there's a whole bunch of security benefits to this, right? Because you're used to replacing all of your images in production, all you have to do is update your base image and run a new push. You no longer have to do kernel upgrade reboots. So this is like one of the biggest pain points I've seen in a lot of organizations where I've run. There's a security update that needs to be done in the kernel, and suddenly you have to reboot every server in your entire production environment. And you know that some of those are not going to come back up. So Instead of having to do that, right, you can now, with Immutable Infrastructure, just push out the new image with the new kernel, with the new security updates, and that will take effect across your entire cluster, and you don't have to worry about that update, reboot cycle that is so painful. And finally, and this is like arguably a smaller benefit, but if you're rebuilding every server all the time, your hackers have a much shorter window in which they can exploit your system, right? If they get root on one of your servers, they might only have it for a few hours before it gets replaced with a new image. I read a blog by a tech company, I don't have a link for it, but last week, where they say they rebuild their entire production infrastructure from beginning to end every single day. And so like the longest the hacker would have access to their systems is essentially 24 hours. Assuming they can't just pop it again. So again, no more snowflakes. If a server is deployed using configuration management, it can hide in the crowd, right? But if you're deploying with Immutable Infrastructure, you at least, even if you had a handcrafted image, even if you went anti-pattern and had a handcrafted image that was built, at least you wouldn't have to worry about the fact that Bob now works at Huli and nobody knows how to rebuild that thing, because you can run the same deployment process to get that same image back. Hopefully, of course, you're using tools to build your images, and it's even easier. Finally, I mentioned databases at the very beginning of the talk. And when I first started thinking about Immutable Infrastructure, it only applied to machines that have no state, right? All of the machines in your infrastructure that you can kill and restart all the time are machines that do transient web traffic, front-end web servers that don't store any data on them locally. But it can actually be done with databases, and I've seen this happen where if you want to do it with databases, you use Docker mount points or SAN mount points inside your container. And this makes it even easier to do upgrades, right? You upgrade your secondary with the new immutable database image. You kill off, or you, fail over to the secondary, make that the primary, and kill off the other one. Or if you're running something better like Cassandra, you can even do that easier. So this talk went a little faster than I thought it would. But hey. I have plenty of time for questions. Here's some ways to contact me. And the slides are up on speaker tag. So with that, I have time for questions.
So we do a lot of deployments of big data clusters.
Right.
Where would you see kind of a middle ground from doing a tear down rebuild so quickly, because that causes massive cluster recopies of data? Is there kind of a middle ground of how to keep yourself low risk? And
depends on how you're running your big data infrastructure, but Quantcast, we used QFS, which is very similar to HDFS. And we could roll Docker images for each file system chunk server, and those would mount the local data storage up into the chunk server using a mount point. And we would shadow deploy the new image to all of the nodes so that the image was out there, was ready to start up. And then we would do a rolling release. So there's basically two methods of doing releases, two normal methods of doing releases with Immutable Infrastructure. One is what's called a blue-green or red-black deployment, where you've got 400 nodes running one version of your software. You spin up 400 nodes running the new version of your software, and as soon as those 400 new nodes are ready, you just turn off the old nodes. That works great for something like a web server, right? There's no state, there's nothing to worry about, it's super easy. If you're on more like a database server, you do a rolling update. So you push the new version out there so it's on all of your nodes, and then you have a process that goes through and kicks each one over to the new. So you're doing it one at a time, and you're not causing a huge storm of network traffic.
right, okay.
What about cost? You talk about reliability. You look at sustainability, in terms of economic.
Well, one of the things that this really enables is auto-scaling. So if some of your infrastructure has a variable load over the day, you can actually scale the number of nodes running the software that you need up and down over the course of the day. So like Netflix has a fixed pool of reserved instances with AWS. And you think, what do you want to do with those nodes at night, right? Nobody's streaming movies. Well, there's very few people streaming movies at 4 o'clock in the morning. But Netflix has this huge work pipeline of movies that are uploaded, and they're uploaded at like 6K or 8K resolution into Netflix's environment. And then Netflix has to, produce a 4K version and a, standard HD version, and then a version that works on your mobile phone. And so it's doing all of this batch jobs that run at night. So you scale down the server infrastructure that serves customers, and you're able to switch some of your infrastructure over to batch jobs, and then go back and forth. And Immutable Infrastructure makes that easy, whereas if you're running everything with configuration managed nodes, suddenly you kind of have to think about how to switch the configuration back and forth all the time. So this actually makes it cheaper and more reliable.
So just the second part of the question, you mentioned Netflix a few times. It makes me wonder if Netflix had to go back and say, I'm going to deploy all my stuff on Amazon or the cloud. Do you think they would have built their own infrastructure to do that in terms of costs, or is that something?
So I'm not going to answer that one on the record, but if you want to find me over a drink, we can have a conversation about how much it costs Netflix to run in AWS. So that's it. We've got a whole bunch of stickers, and I think there's socks somewhere for the code team. So if you guys want to come up and talk afterwards, or find me in the bar or whatever, I'm always happy to answer questions.